Thanks, David. Good afternoon, everyone. Thanks for joining us today for our discussion around AI and advanced analytics on national security. I'm Raymond Presti, a Senior Solutions Architect at GovernmentCIO, and I'll be moderating today's talk. Let's get started with our panel. Let me introduce Dr. Jill Crisman, the Principal Director for Artificial Intelligence at the Research and Engineering at the Department of Defense, Professor Daniela Russ at the Computer Science and AI Lab Director, MIT, also a member of the Defense Innovation Board, Brian Gattoni, CTO at CISA, and Jim Richberg, CISO at Public Sector Fortinet. So I want to get started with an open question to the panel. And let me preface this by saying the first two segments we heard around artificial intelligence and data, around the GSA's use of it, around our healthcare use of it, and our focus around national security and intelligence. So very open question here. How has artificial intelligence and data analytics impacted your respective areas? Jill, you want to kick us off?
Sure. So as Principal Director of AI for Research and Engineering in the Department of Defense, I look at the potential of AI to revolutionize the defense of our country. AI holds the promise to more rapidly and accurately detect threats, fuse multi-domain information sources to understand the operational picture, make faster and more advantageous tactical decisions, and predict possible tactical and operational outcomes. The end result will be a quickening of the pace of combat and the significant advantage to the military that can adopt and deploy AI most effectively.
Thanks. Professor Russ?
So let me build on what Jill said. I'm a professor. I'm a scientist, and in my field, I have seen a bonanza of activity because all of a sudden, these technologies that we have been working on as researchers, as educators for decades, are now making an impact, and the impact is really broad, and there's so much optimism for the kinds of things that we can do with AI. We can move things, people and goods faster and more efficiently. We can better diagnose, monitor, and treat disease. We can keep your information private and safe. We can enable communication across the globe, no matter what your language, much more easily. We can ensure that our roadways are safe. In general, we can offload to machines, low-level routine tasks, so that people can focus on higher-level activities that require critical thinking. And there's so much opportunity in business, in national defense, in education, in research, because I should tell you the technology is not perfect. We still need to advance it. In fact, it's important to, as we think about AI, it's important to remember that despite this great promise on the technical side, some of today's greatest advances are due to decades-old ideas enhanced by vast amounts of data and computation. And so we need new technical ideas. We need the funding to back them, and we need more people understanding and working in the field. We also need infrastructure so that we can deliver on the promise of AI. Now, with respect to national defense, I just want to flag one project we are doing at MIT. It's called the Ai Accelerator. It's a project we've embarked on together with the Air Force, and the objective is to speed up the time it takes to get ideas from the research lab into production, especially for defense applications. And in our project, we have interdisciplinary teams that include MIT researchers from Lincoln Labs, Air Force, Airmen, and we're all working together to advance the science and engineering of intelligence. And then with the domain expertise from the Air Force and from Lincoln Labs, the idea is that those new advancements could then be well understood and taken towards product development much faster, definitely much faster than without being together to see how the basic technologies is being developed.
Fantastic. Thank you, Daniela. Brian, what's your perspective from CISA?
So our perspective at CISA is core to our mission. We serve as the nation's risk advisor. Through our efforts to understand and advise on cyber and physical risks to critical infrastructure, we help our partners strengthen their own resilience and their own capabilities. We connect our stakeholders in industry and government to each other and to the resources, analysis, and tools that helps them build out their own cyber, communications, and physical security and resilience. And in turn, that strengthens national resilience. And if that's our operational calling, then the logistics that supports that operation is data and analytics. As a risk advisement organization, we bring in data, we do our work to add value to it, and then disperse it to those that need it and can consume it for their risk decisions. We do this in a number of operational priority areas. One, improving the supply chain security against cyber threats from malicious nation-state actors, and specifically in the rollout of 5G technologies. We help protect federal networks in the civilian.gov domain. We have responsibilities in soft target security, election security, and critical infrastructure protection, including industrial control systems and the processes that provide vital services to our critical infrastructure. All of the data that supports decision-making in these areas can benefit from a robust conversation on how data and analytics can improve and where the promise of artificial intelligence can help us make good decisions faster. Whatever quality of positivity you ascribe to what you want out of artificial intelligence, we're interested in that conversation as it relates to managing risk to national critical functions. I appreciate you all having us here for this conversation.
Thanks, Brian. Jim, you got the public perspective from the public sector.
So, you know, Ray, I spent 34 years in the intelligence community, and now I'm 2 years into working with public sector customers at one of the world's largest security companies. And from this latter perch, being in the private sector now, AI and machine learning are absolutely foundational to our ability to operate for the big cybersecurity providers like Fortinet. And if you look at the scope and scale of what we're trying to do, I think it's pretty self-evident. We work with 500,000 public and private sector customers with networks worldwide. We deployed at their network edge, we're in their core, we're in their cloud. And with the devices we've got in those environments that are both sensors that are generating the data that's coming back to our global security operations center and threat research group, it's generating on an average day 100 billion or more, billion with a B, security events that we need to look at. There's not enough people on Earth, much less on our payroll, to make sense of that data, absent AI and machine learning, to allow you to do the kind of correlation, to recognize that most of these are just odd but not malicious, and to figure out how to operate against this. So there's no way you can get this kind of global understanding of what's going on, much less build a common operating picture and then respond to it without using AI and ML. Otherwise, this industry would be not federated. We'd be providing siloed capability to specific agencies.
Great. Thanks, Jim. I'm going to change the focus here and move away from the technical aspects of AI and look at the ethical aspects of it. I think we could all go back to last summer, and there was an uproar about the use of facial recognition. Now, I picked facial recognition. We could use artificial intelligence within drones and the autonomous nature of drones. But my question is, how do we balance the growth of AI in law enforcement or in national security with ethical considerations, considerations around privacy? Daniela, would you like to kick us off with this one?
That's a very good question, and it's very important. We have a very powerful technology. We have to be responsible. We have to think hard about how to use it. So with respect to the specific case of face recognition, I would like to say that it's known that all the algorithms we use in machine learning depend on data, and their performance is only as good as the data used to train them. There are known biases, and since last summer, we have had increasingly more results that talk about biases in these systems. So we have to understand how the technology works. We have to understand when the technology doesn't work. And then we have to think about what to do about it. With face recognition, the bias is extraordinary. And it's been documented so many times that, the response of face recognition is different for according to race. And in particular, it's very bad for women with dark color skin. So what to do about that? Well, some of the solutions can be technological. For example, in my research group, we are working extensively on algorithms that allow us to assess the uncertainty of a machine learning model, tie that to the uncertainty in the data used to train the model, and then fix the bias, debias the system. And so there can be technological solutions that we could adapt. But then as we think about the applications for these technologies, including face recognition, we also have to consider what is right, what is not right. What can the technology do? What can't the technology do? When should we use it? When should we not use it? And I would like to share with you 5 principles for AI ethics that was developed as part of our work with the Defense Innovation Board. And so the principles in our report include responsibility, meaning that human beings should always exercise appropriate levels of judgment and remain responsible for the development, deployment, use, and outcomes of AI systems. The second is equitability, meaning that we need to take deliberate steps to anticipate and avoid unintended bias and unintended consequences. Third is traceability, meaning that the AI engineering discipline should be sufficiently advanced such that technical experts possess an appropriate understanding of the technology, of the development process, and the operational methods of AI. And as I said in the answer to the previous question, there is much to be done to address some of the limitations of today's AI systems. The fourth principle is reliability, meaning that AI systems should have an explicit, well-defined domain of use, and the safety, security, and robustness of these systems should be tested and assured. And the fifth principle is governance, meaning that AI systems should be designed and engineered to fulfill their intended function while possessing the ability to detect and avoid unintended harm or disruption and pass control over to those users. So beyond these general principles, we also need to look at all technical advances with both an eye towards what benefits they can have, but also what policy actions are needed to stem possible dangers.
Thanks. Jill?
Well, I have to thank Daniela because she covered a part of what I wanted to talk about, because I was going to actually address the DoD has adopted actually those ethical principles that the Defense Innovation Board had suggested. The Secretary of Defense signed them in February of this year. So it's actually February of 2020. So they've been in effect for a year now. But it's you know, those are actually governing somewhat how you build AI, but there's also how we use it. And one of the things that's within the Department of Defense, we have laws of war. And those laws actually extend to using autonomous systems, of which sometimes AI is counted as. And these laws actually help ensure that AI-enabled systems or any other system that's autonomous that we deploy in the department are ethically deployed. And so we have scientists and engineers working with academia and outside to actually examine those laws and determine if these need to be updated based on the advent of AI. But this is something the department is seriously considering. So we are taking seriously the ethical use of AI in the department and studying it very carefully.
Fantastic. Thanks, Jill. Thanks, Daniela. Let's move on and look at the actual impact of AI on cybersecurity. Let's look at cybersecurity, if you will, from both a defensive nature and if you wish, an offensive nature. Brian, as the CTO at CISA, how do you see AI impacting you and safeguarding the cybersecurity of our infrastructure as well as DHS?
So as the CTO at CISA, I look at new and emerging technologies from three perspectives. One, a sort of selfish perspective. If we adopt a technology for our mission use, how's it going to help us do our job? Two, if our stakeholders or customers adopt that technology for their business enterprise, what does it do to their attack surface or risk profile, whether they're using it for cybersecurity or just their general business? And then three, because our adversaries get a vote in the risk equation, what does it mean for our adversaries to potentially leverage this technology to drive their means? And then the counter move to position ourselves to be successful, to protect our stakeholders, and to deny our adversaries their goals. How I see AI impacting cybersecurity for this conversation, I think it's interesting to discuss from the stakeholder view what it means to improve your use of artificial intelligence, machine learning, and data and analytics technologies in your enterprise. These are now, robust and complicated systems with a changing IT infrastructure, with changing data standards. It takes some of the general cyber hygiene rules that CISA's been pushing quite a bit to the forefront when you're talking about data that's used to automate decisions and optimize your enterprise. That data is now probably higher value than you may have considered it before, and that bears some burden to protect it a little bit better. You don't want to invest heavily in an enterprise in a data and analytics infrastructure that optimizes your output and not consider the risk of that data being locked up in a ransomware campaign. So if folks are interested, I could push them to the CISA.gov website, where we've recently published out a reduce the risk of ransomware campaign to get focus and coordinated effort on the idea that data as a critical asset for your enterprise is subject to ransomware problems, and they can lock you out of it and really do damage to what it is you do. And for us, for our customers who are providing nationally critical functions, we have a vested interest in making sure that as they adopt these advanced data technologies, that they do so in considering the cybersecurity implications for loss of access to that data to their enterprise, loss of that data in terms of it being stolen for others, or to where you've started to incorporate that data into artificial intelligence and machine learning algorithms, how that data could be manipulated, poisoned, or changed to cause you to make different decisions than you had intended to. And all of that's in the risk equation and understanding where artificial intelligence can help you, but also presents an opportunity to increase your attack surface. And we just ask that folks really maintain awareness of those dimensions as they move into this space.
Thanks, Brian. So Jim, how, as from the public sector, how could our vendor community help CTOs like Brian meet his objectives and safeguard the infrastructure?
So Ray, we actually, I think, are on the cusp of a transformation. And I always say this with reluctance because I don't want to sound like a fanboy for AI as the latest fad, but I think the intersection of increasingly mature and powerful AI and ML in the cybersecurity industry, and the reality is that industry has been using it in production for a decade. We got into it not long after some of the big firms we think of for big data analytics started doing it. So we've been using it, we've been getting better, we're using it more broadly now, but the intersection of that with this idea of broad platforms, common sensors and controls that don't have to come from one company, but that share an ecosystem that can feed a common data lake that can support each other, instrument the attack surface. And that generates the data, and the AI and ML is increasingly becoming the decision engine for correlation, for making sense of it, and then for policy-driven automated action to take advantage of it. Again, I come at this from the perspective of somebody who played offense when I was in government. We were never invisible, omnipotent cyber ninjas. We would typically try and fail before we get into a network. We would hope our failures would look like anomalies rather than something intentional. We relied on the fact that the defenders can't be looking everywhere all of the time. And even if they did see us in action, they wouldn't know if that's a false positive, which most alerts are, or a genuine event. And if they thought it was significant, is it a nuisance, a tier 1 alert, or something serious? And if it's serious, how do I respond to it? That's what attackers have exploited. And this is what this broad attempt at instrumentation powered by AI and ML puts you in the position of changing. And there are niches, it's an arms race. There are parts of AI and ML that will asymmetrically favor the attacker. One that springs to mind is using AI for generative content for spear phishing. That's one where even open source programs are getting good enough to fool the experts. So look at the spear phishing now to not only steal your user ID and your credentials, but your email inbox and outbox so that the stuff comes out tailored enough to fool their experts. But on balance, this is a data-driven arms race that the network defenders, I think, are positioned to win.
Thanks, Jim. Jill, looking at defense, and this is also open to anyone else who would like to pitch in an idea here. Obviously, this is all data intensive, and the warfighter has to make decisions faster. We have on the verge of hypersonic weapons flying at Mach 6. How are you looking at the ability for you in the DoD to collect and fuse data from the various sensors and sources to develop this common operating picture that the warfighter then can use?
Yeah, so, you know, the idea that AI can fuse and aggregate all that data and create a common operating picture is an idea that's been around for a long time. But certainly the big data and machine learning revolution is actually providing real opportunities now to actualize those visions of that common operating picture, which we've in the past had difficulties obtaining. So we can now look to a new generation of things like the command post of the future, where we can move beyond sort of tactical decision making to address the harder problem of sort of pre-conflict understanding, like potentially the Strategic Capabilities Office's C2IE effort, which is looking at, you know, what's happening before we're actually engaged in war. But beyond specific programs like this, you'd like to talk about the potential to address this intelligence fusion and decision-making process in an agile way. So it's not that these weapons or these people are going to have a static thing. Our adversaries are constantly changing their attack. So we need to have sort of users in the loop. We need to make evolutionary changes. And we need to push improvements out every day instead of every other year. And then we need to receive user feedback immediately. So I view a lot of this sort of common operating picture as actually adapting to the various, as our adversaries change their attacks, we need to actually adapt to that and put new information into that common operating picture to run effectively as a military. So very fascinating in the department right now, we have software factories. They're developing these types of capabilities to actually update software and redeploy it. They're starting to adopt machine learning, and we want to basically adopt better and more machine learning in that process. And I want to encourage these software factories to actually sort of be involved in rapidly developing software so that we can actually expand our capabilities in these warfighting domains.
Great, thanks, Jill. Daniela, from an MIT perspective, you're on mute.
Can you hear me now?
Yes.
Yeah, so the question of fusing and collating data is very important from a technological point of view. It's because data brings different aspects of different data brings different aspects of the situation awareness, and so it is really important to develop algorithms that are efficient and integrate multiple types of data. The applications are broad. The applications include medicine, where maybe you have handwritten notes that need to be fused with imaging data items, and similar heterogeneous data streams occur in national defense and in other applications. And so this is a very hot topic, and people are working on this. I will tell you that in one of our recent results, we've been looking at how to integrate camera data with laser scanning data to enable better autonomous driving. And we have found that by integrating the two, we can do things that we couldn't do with one or the other individually. And so in particular, we can better detect the model and type of the vehicles surrounding the ego vehicle, what else they're doing on the roadways. And so this kind of higher level abstractions that can be learned by combining multiple data sources are very promising.
Great, thank you so much. Hey, Jim, I'm going to ask you for your commercial sector perspective again, and I'm going to look at the other panelists to basically ask Jim for, if you had a wish list of what the vendor community could do, and see what he would think about it. But in this case, Jim, how do you see AI assisting specifically the security staff in managing those billions of cybersecurity incidents, everywhere from the identification through the remediation and the automation of the entire process?
It's a force multiplier. You know, depends on whose numbers you believe. We're multi-million people short in the cybersecurity field, and they don't have the right skills. And I've got to tell you, there's nothing more demoralizing than taking one of those relatively scarce people and saying, your job in the Security Operations Center today is stare at this screen and look for an anomaly. It's a little bit like the Maytag repairman. Yes, there's going to be a bunch of them. Most of them are false alarms. That kind of rote activity is something where AI and machine learning can definitely help. Let the people do things that require human judgment. Jill talked about, when do you put the human in the loop? Even for things like situational awareness and common operating picture, you need to recognize it comes in two flavors. There's one that's machine to machine. Brian lives in this world too. When I see a board of threat activity about something that's happening in cyber, that's a time machine. I'm looking backwards. It's a current connection, but if there's data flows, I've already lost that data. So I need machine speed for response. I also need human speed response. A human needs to decide, I want to change my alert color, I want to change my alert posture. So you're trying to feed two kinds of audiences, and AI and ML definitely helps us say, our people can do the things that require people. We can automate the rest of this. And this capability has been getting good enough in the private sector that we can now give to government what are now fairly refined algorithms, and as much to the point is training data. We look at these hundreds of billions of pieces of data, and we've discovered, you know, there's 6 to 10 million that actually is a reasonably good training set to let us give you a lightweight algorithm that you can deploy in your environment, reporting into your Security Operations Center, because we recognize there are parts of government that aren't going to let even telemetry about threat activity go off premise, whether it's classified, whether it's just covered by other kinds of policies. So that's where the private sector can now say, look, we can help you both at the machine-to-machine response and informing people, the ability to look at a threat board and say, here's something happening, I need to talk to someone and coordinate a response.
Thanks, Jim. So
yeah, I think, if you don't mind, Ray, I think Jim's exactly
good.
spot on. And I think what feeds the conversation is some responsibilities on both sides. So I'll talk about the government, as a customer responsibility. You have to know your own processes and your decision-making paradigms. You have to have that playbook to know when your human has to be put in the loop, because context is everything. You could take a data stream and a threat and make one decision in a certain context that absolutely doesn't work in another. And let me be specific about that, right? Drawing in all the data of a possible DDoS attack on a networked capability that goes into a triage process, right? We can put artificial intelligence and machine learning on triage and reduce those false positive, false negative rates and put information in front of an analyst that is more meaningful than just having them stare at the screen. We give them another layer and they can decide what to do next and take an action, right? But let's take that same data stream and flip it to a different type of networked capability. Say in the event of a next-gen 911 call center that's under attack from a telephony denial of service. AI and machine learning may be able to detect that that attack is coming based on, stream rates and inbound. But would we automate a response to that without humans on the loop? I'd say absolutely not. That's where life and safety kicks in, and the ethics rules we were talking about earlier really kick in, that you don't then shut off incoming traffic to a next-gen 911 call center, because there's going to be legitimate traffic affected by those kinds of decisions. So when you go to automate or leverage machine learning in your decision cycle, you really need to know where the human's going to come in and what the benefit and regret matrix is of automating that decision. And then for the vendor community, as they're bringing these robust technologies to the customers, be specific about the types of data that the customer is going to need to have access to and the rate at which they're going to have access to it to get full value from the algorithms and the machine learning that you have so bespokely trained up on a data set, right? It could be that your customer doesn't have the routine access to the data they need to power that system, and it's not going to be a full value to them. And so having conversations about data access and how much and how often to really take full advantage of these systems, I think could knock down a lot of frustrations in the buyer-consumer conversations in these advanced areas.
Great, thanks, Brian. Daniela or Jill, anything to add before we move on? Okay, cool. Hey, I have a question from the outside. I wanted to say it was a call-in question, but it's actually a text message. What skills, and this tends to be more within your organization, what skills are you looking for in individuals that would like to join your organization? Open that up to anyone.
Well, at MIT, we are looking for excellence. We're looking for passion. We're looking for great background in computing, and really for people who want to invent the future.
Okay, thanks.
I'm going to broaden this because I don't know that I want to make it specific to AI and ML. I think there's this common misunderstanding that cybersecurity requires programmers. You actually need people with good human skills, people who work on a help desk, people who, even from a threat perspective, understand social engineering. So, some of the best people in cybersecurity are actually liberal arts backgrounds. Some of them even only have associate's degrees. So, breaking this idea, yes, we have this broad paradigm, the National Initiative on Cyber Education, nice, laid out all these different career paths, but the idea that you have to be technical and that you have to come from four-year things with credentials is something where we absolutely say it's having a creative approach to problem solving is actually more useful than any specific set of technical attributes or characteristics I could tell you to have.
I couldn't agree with Jim more, and I'll amplify it. Right here in America, we celebrate a diverse pool of workforce that come in, and that diversity of thought is an asymmetric advantage that our nation holds over some of our adversaries that don't celebrate some of those same values. And if we can harness that in the workforce that's applied to these problems, we stand a really good chance of winning, and quickly.
And I want to second everything that you guys said as well. The Department of Defense is huge. So we have a lot of talent. We need subject matter experts on cultures around the world. We need to have, of course, our soldiers and military personnel. But as far as the technical expertise for software development or even AI development itself, there's a huge range of expertise that you need. There are things you can do to adapt particular machine learning algorithms to try to tackle new problems. Needs less expertise than potentially what you might need if you're actually developing deep neural net architectures that are challenging new problems. So I'm going to second everything that people are saying is not just a broad background of people that we need, but also a broad swath of technical skills and a willingness to serve the country and wanting to defend the country is what we're looking for.
Fantastic. Thank you all. I think we have time for one more question, and I wanted to get this in. And this one's primarily for you, Daniela, and then obviously anyone else could add into the end. I was amazed when I read your bio and the CISO and all the technological innovations over the last 50 years that they've been involved with. So I want you to put your researcher's hat on and look into the future in the crystal ball. How do you see the global information infrastructure changing? I'd want to say 10 years, but that's probably too far out. Maybe within the next 2 to 5 years.
Well, first of all, I should say that right now we don't have the appropriate infrastructure to broadly take advantage of machine learning and AI technologies. And so this has to be improved. This has to be stepped up. Nobody has it. So we have to think about how to change our communication networks to communication data and computation networks. Machine learning relies on huge amounts of data. And many of the models that we are developing are very large. For instance, this summer, a new natural language understanding model was trained. The model is called GPT-3. And this model achieves very good performance. It's not a universal language model, but it's very close to the accuracy of what you might expect from a universal model. This model was trained on every text that is publicly available. It's huge. It's got billions of parameters, so running models like this, for whether it's for research or for business applications, running models like this requires much beefed up computation over what we have now. And so yes, I think that we have a real opportunity to think about what the computation infrastructure for the 21st century looks like. And this could put all of us in a leadership position to achieve something better than what we have now.
You're on mute, Ray.
I apologize. I was on mute. Jill, from a warfighter perspective, how does this infrastructure look?
Well, I was just going to add on to what Daniela said, because as more and more companies and governments and military sort of adopt these deep learning technologies that she was talking about, our demands are going to rise exponentially. This also means that the power demands for computing are also going to increase, which also impacts climate. So there is a need for us to invest a lot more into lower cost, lower power computing for deep learning and AI. In addition, more research into lowering the data requirements, as well as the computational costs of actually some of these deep learning algorithms. So I'm going to champion some of the research that Danielle wants, but also to talk about, as this infrastructure grows and more people want it, we have to seriously consider how do we make it more efficient.
Thank you for saying that, Jill. It's absolutely the right thing. We have to invest not just in infrastructure, but we also have to invest in the ideas. We really have to innovate, because otherwise we're going to plow the same field and the results will be increasingly more incremental.
That is absolutely true. And I want to thank you. There's a little voice in my ear that says our time is up. It's amazing how quickly time flies when you have a great conversation. I want to thank everyone on our panel and everyone out there that has joined us today. Please stay online for the next session, which is the power of AI, being moderated by Amy. Thanks. Take care.